everyone. Welcome to our today's webinar topic. So before that, please confirm me if I have joined that if I am audible or not properly. Okay. Okay. So okay. So let's start with our today's webinar session. We are completely it's a completely very amazing topic that in statistics, that why the sample variance is divided by n-1 in stats. Okay, so before that I have to introduce myself. Hi, I am Tapashwini Naik. I have been a consultant trainer at Sankhyaana Consultancy Services with an experience of 2 years in providing training to data science. Okay, so let's start with today's session and let's make this session very interactive. So I have to share my screen. Okay, so why sample variance is divided by n-1 in statistics? Before that, I have to discuss that what is our today's agenda. So our today's agenda is first of all we are going to discuss about what is statistics, a very brief introduction about statistics. Those who are here who know about that, okay, what is statistics, who have the statistical knowledge and all, they will get very familiar to this term. But those who are not belong to the statistical field, don't worry, I will make you understand. Okay, so after that, after having an introduction about the statistics, we are going to learn that, okay, what are the type of statistics. Sure, then we are going to know about the population and the sample data, what are the type of data we have. Then after that we are going to discuss that what are the population mean and the sample mean in descriptive statistics. Then going forward we are going to learn about what is variance and then why sample variance is divided by n-1. Okay, so okay, what is statistics? So statistics is a science that deals with the mathematical methodologies to visualize, analyze, organize the data into pictorial or non-pictorial mode and draw some conclusions. Okay, so statistic is nothing but it is a science. It is we can call it as a mathematical science that deals with the data. Okay, that deals with the data which is used to visualize the data, to organize, to summarize, to manipulate the data and to draw some conclusions. How we can draw in the conclusion? By manipulating it, by calculating some results, or by displaying it through a graphs, through any pictorial or non-pictorial mode. Okay, so in data science what happened, the statistics is widely used in cleaning, manipulating, translating the data patterns into actionable evidence. So when we are getting a data in statistics, in data science, when we are getting a data, what we have to do, we are getting a raw data, right? After getting the raw data, so we have to clean the data so that it will give us a predictive result when we are going to pass some machine learning models, or when we are going to use the data for any of our data science project and all. Okay, so cleaning, manipulating and translating the data patterns so that we could establish some relationship between the variables that are present in a data, between what type of data it is, what we can do with the data, what actions we can perform. Okay, so it allows you to evaluate the claims based on quantitative evidence and help you differentiate between reasonable and dubious conclusions, right? So when we are converting the data in our statistics, we do various of methods, we do various of analysis, we are using quantitative methods, we are using hypothesis testings and all. So this all we are going to learn further. Okay, so now come to what is the types of statistics. So the type of statistics we have is the descriptive statistics, and one is our inferential statistics. Okay, so let us know about what is descriptive statistics. So descriptive statistics that deals with the organizing and summarizing the data. When we are talking about the descriptive stats, it is nothing but we are just talking about the organizing and summarizing the data. How we are going to organize and summarize the data? Suppose we get a data which is in a very large amount. Okay, so descriptive statistics, we can tell it as, in the count noun sense, is a summary statistics that quantitatively describes or summarizes the features of a collection of information. So the collection of information is nothing but it is the data. Okay, we are going to pass out what the quantitative analysis on that. It deals with the various type of the measure of central tendency. It deals with the measure of dispersion, the variance, the standard deviation. It deals with removing the outliers. Okay, so basically in descriptive stats we are going to compute the mean, the median, the mode imputation on a data, right? So these all are getting under the descriptive statistics. And coming to the inferential stats, what is happening in the inferential stats? The data that we have already organized and measured in the descriptive statistics. Okay, so after the measured data we got, we just pass some technique to draw the conclusion from the data that we have measured. So basically in the inferential stats, what we are doing now, we are drawing the conclusions from the measured data that we have drawn from the descriptive stats. We are using the descriptive statistic using the mean, median, mode imputation, by removing the outliers, by calculating its measure of central tendency, by calculating its dispersion. So we are getting some, we have to draw the conclusion using the inferential statistics. So statistical inference is the process of using data analysis to deduce the properties of an underlying probability distribution. Basically what happened in the inferential stats, in statistics we know that we have a probability distribution, right? So what kind of outcomes we can analyze, what kind of outcomes we can it can be probable. So these many techniques we have in the inferential stats to measure the conclusions. Inferential statistics analysis infers the properties of a population, for examples, by testing hypotheses and deriving the estimates. Okay, so it is assumed that the observed data set is sampled from a larger population. Inferential statistics can be contrasted with the descriptive stats. So in inferential stats, what happened? Now the methodologies that we are using, that like the hypothesis testing, we have the J test, we have the T test, we have the chi-square state test. So this all we are having in the inferential stats. Okay, so coming to the data part. What is data and what are the types of data we have? So basically here we are going to learn about what is the population and sample data. So data is nothing but it is the collection of facts or pieces of information that can be measured. Every day we are getting tons and tons of data that are generating in this world. Suppose here I am sitting with you and giving you the demo of this particular topic, on this particular topic. So in this half an hour or in this 1 hour or in this 10 minutes, the whole means a lot of data are generating across the world. We don't even know about it. It is completely beyond our imagination what is the amount of the data that are generating in each and every second. Okay, so based on the data properties, based on the data the types, we have we have the discrete data, we have continuous data, we have qualitative, we have quantitative data, and we have population and the sample data. So basically as per our topic, so here we have to discuss about the population and sample data. What is the population and sample data? Let's I'm giving you an example. Suppose we all know that suppose there is a election going in a state. Okay, so after when the election get completed, there is the exit poll, right, to calculate that okay which party is going to win this election. and this exit poll, the survey was getting conducted by some reporters, right? So at that time what happened, that the reporters were instructed that okay, just visit the people over that state and do a survey that okay, according to their opinions we can calculate that okay, which party is going to win. Then the reporter went out for the survey part. At that time what happened, the whole population of that state, when it come into the consideration, is it possible to that, suppose the count of the reporters will be around 10 or 11 or 12 reporters there. Okay, is it possible for that 12 reporters to go and ask each and every people that are present in the state? Is it possible? No, right? It is not possible to ask each and everyone and have their opinion that okay, which party is going to win or to whom they have voted, right? So at that time what they do, they collect some sample. There are around 5 sampling techniques are there. So they collect some samples. They collect suppose few people from this category, few people from this category, and they make a group. Okay, look at this picture. So this is the whole population data we have, and when they randomly pick some people, okay, it is known as a random sampling, and they just make one group. This is the sample data. Okay, so on this sample data, what they do now, they just go and ask these people that okay, which party is going to win according to you or to whom you have voted. Based on that, they made some clusters, then based on that they will draw the conclusion. So it is not possible to compute a statistical analysis on a population data. That's why the statistical the researchers came up with the sample data. Okay, so here let us see the definition. A population is a group of phenomena that have something in common. The term often refers to a group of people, as in the following example, like the population of a country. Okay, so it is nothing but what is the for example, what is the total votes collected for the state election, that I have already told you. And what is the sample data? A sample is a group of it is a group of population data, okay, that is selected to represent the population. So this sample, this sample data, what it represent the population data, right? Because where we get the sample, from this population data only we have got the sample. Okay, so this is completely about the population and the sample data. When we collect one data, okay, when we collect the population data, so first of all, in the descriptive stat, what we do, we calculate the mean. We have to calculate the average, right? So when whatever data we get, so first thing what came to our mind, okay, what is this data? By viewing the data, what is the type of the data, and after that we are calculating its average. After the calculation of average or after the calculation of missing values and all, then only we go forward for the further computations on that data. So now what do we mean by the population mean and the sample mean? Based on the data we get, population mean is nothing but the average of the whole data that has been given. Okay, so it is nothing but it is the average, the midpoint of all the data, whole data that has been given. And how we are going to calculate the population mean? We have the formula mu equals to summation of x by capital N. Okay, so the population mean, always remember that the notation that you are giving for any function, okay, that you are giving for any function, the notation should be understood by you and also for the front people who is going to evaluate you, okay, or who is going to read your paper or something. Okay, so here stream must get understand about the notation that you have given. So what is the, so here the mu is nothing, mu is denoting the population mean here. Okay, so here the summation of x by capital N is nothing but the x is the sum of the total number of observations, and here n is the total number of observations. N is nothing but the total number of data we have, and x is the sum of all the observations that we have. By this we can compute the population mean. So Sample mean, it is nothing but it is the average of the observation that has been made from the samples we collected. When we are going to calculate the average of the sample data that has we collected from the population data, always remember the population is the whole data and the sample data is nothing but it is the part of that population data that we collected for our analysis. Okay, so this, when we are going to calculate the average of that sample data, at that time we can call it as, it is our sample mean. So what is the formula of the sample mean? It is nothing but x bar. We denote the sample mean as x bar here, equal to summation of x of I divided by small n. The small n is nothing but it is denoted as the total number of observations here, and x of I is nothing but it is the sum of the observations. Okay, so understood about the population mean and the sample mean. Okay, now come to know about what is the variance. What do you mean by variance? So variance is nothing but, okay, when we are calculating the population mean or the sample mean, we got the midpoint, we got the mean of that particular data. Okay, in a layman way, when we get the midpoint of that particular data, have you observed in a graph that, okay, where means our data is, how far our data points are present in that graph? Look at here. This is our mean, okay? In this part, this is our mean. For this graph, for this A graph, this is our mean. So our data points must be here, must be here, must be here, must be here, must be located in this part also. It is a mid part, right? Okay, so must be here. So when we draw a graph by joining these data points, our graph look like this. Okay, so variance is nothing but from the mean how far our data is got spreaded. Okay, how our data has got spreaded, that is only we call this a what? Variance. Okay, so it is a measure of how far a set of data are spread out from their mean or the average value. Variance means to find the expected difference of deviation from its actual value. Okay, so therefore variance depends on the standard deviation of the given data set. So standard deviation is nothing but it is the square root of the variance. Okay, so now come to know about what is population variance. It is very simple. As per the name, consider, we can make the assumption that, okay, population variance we can denote is as sigma square, tells us that how data points in a specific population are spread out. It is the average of the distances from each data point in the population to the mean squared. Okay, we will the point in the population to the mean square we will going to know in its formula part. Okay, you will get very clear about the definition what it has been written here. Okay, so population variance is nothing but with the population data when we are going to calculate the mean. So from the mean how far our data points are situated, when we are going to calculate those distance, that is called the variance. And in the sample mean, what happened? Now in the sample mean, when we collect the data from a sample, the sample variance is used to make estimates or inferences about the population variance. Okay, always remember that what you are doing with the sample data, it always relates the output, the result of the population data. If you are calculating the mean, also it is going to resemble the population mean. If you are going to calculate the variance, also it estimates or inferences about the population variance. Okay, whatever your computation doing with the sample data, at last you are going to compare it with the population data values, whether it is the mean, whether it is the population variance, whether it is anything. Okay, so let's see. Here I have already viewed this example to you. So in this graph, what happened? In the A graph, just look at here. So it is quite spreaded, right? It is quite spreaded here. So this gap, okay, this gap is nothing but these are the data points. These are the data points. Okay, so here our data spread is more, right? Means most of the data are present in this region. But look at this B graph. what happened, this is means this is pointing tilde here in the middle, and the data spread is more, right? The data spread is less, sorry my bad. So the data spread is less here, means less amount of data is present here, right? So variance is nothing but it is something that we call it as where if we have two data set, okay, if we have two data set, their mean is equal, their mean will be of similar, their mean is equal, but their distribution is different. Okay, the spreadness is completely showing us how the data is distributed. Look at here. Okay, here is mean 5% and here is also the mean is 5%, but look at the standard deviation and the variance. Got it? So the what is the formula for the population variance? We have summation of I equals to 1 to n. Here x of I minus mu of whole square divided by small capital N. So here x of I is nothing but it is the sum of the data points of the population data, and here mu is the nothing but it is the what? Population mean. Okay, and here capital N is nothing but the total number of observations. And in the sample variance we calculated it as, we denoted it as small square. Here what happened, the xi we know that it is the sum of the observations, x bar we know it is the what? Sample mean, but y, have you ever looked at here that it is dividing by the n-1? Why not by only small n, the total number of observation? Why it is divided by the n-1? So this is very important to know, why sample variance is divided by n-1. Okay, and also it is known as the basis correction. This term we usually come up with the interview questions. Okay, so they just ask like, okay, what do you mean by the basis correction, and people got stuck in that part. Okay, so now come to know, the larger the sample is, the closer its variance will match the variance of the population. Okay, so when the sample data is larger, its variance will be very closer, that it will match the variance of the population. So the less compensation is needed. Okay, the n-1 deals with this perfectly, since the difference between n and n-1 becomes negligible as n becomes large. This definition is now, it is looking like very hard to understand. Okay, let me make you understand with an example. Okay, suppose we are taking a population data and calculating its mean and variance. Look at here. Suppose this is the graph of the population data here. Means from this point to this point we have data. Ignore that this means small and that upward line and downward line. Okay, just assume that there are the data points present in this line. Okay, so of this whole data point, if we are going to calculate the mean, so it is going to point here. Somehow it will be going to point here, the midpoint of the data. So it is the total the population data. We know that we have to do the sampling technique. Okay, we have to collect the sample. Suppose one person is going to take some sample data from here, from this part to this part. Okay, so suppose from this part, this 55 to 60, he is going to take some random data. Just pick out some random data that comes in between the 55 and 60. Okay, so if he is going to calculate the mean over the sample data, then obviously the mean will come over somehow here. So if we measure the distance from this mean, from this sample mean to this population mean, okay, so the distance is very less, right? The distance is very less. It is okay. It is okay for the computation. It will predict the good result. Suppose we are taking from this part, also the mean will be approximately nearer to the population mean, right? When we are going to calculate the picking the data from this point, the sample mean will become over here. It is also okay if the sample data will get extended, means if the sample data will get large, then obviously the mean will come forward over this somehow for this point. So it is also okay. But if we have some skewed data, remember skewed data is nothing but when our data point is lie in the one side. Just assume that a person is taking some data sample from this point, from this part. from the end. Here also data point are present, na? Okay, so he is going to take out some random sample from this point and calculated mean. What happened here? The mean is somehow falling over this point. Okay, suppose from this part, the mean is falling over from this part on this point. Have you ever imagined that the mean from this part to this part, from the population mean, the sample mean is how far, what is the distance? So this will cause a very big problem when we are passing the data to our data science model. It doesn't give us the predictive result. Always remember, the sample variance or the sample mean that we are calculating, at the end it will be approximately equal to the population mean and the population variance. Okay, so for that reason, what happened? Now the researchers calculated that they have been doing the many iterations with by computing it, by dividing it with n, then n-1, then n-2, then n-3, n-4, and later on. And after doing so many iterations, after doing so many research, they have come up with a result that okay, when we are dividing the sample variance by n-1, this distance from the population mean, from the population variance, the distance of the sample the distance of the sample mean and sample variance is getting reduced, is getting maximum when we are dividing it by n-1. n-1, it is nothing but it is also called as the unbiased estimator. Okay, so when we are dividing by n-1, when we are subtracting the total number of observation by 1, at that time what happened? Now the sample variance is getting closer, the distance is getting reduced to the population variance when we are getting calculated. For that reason, the sample variance is divided by n-1. It is known as the Bessel's correction, and the n-1 is called the unbiased estimator, or we can tell it as the degree of freedom also. Later on we will learn about the degree of freedom. So when this n-1, when the sample data, when it increase, suppose we have chosen some random data from here, right? Suppose when the population data increase, obviously the sample will also get increased. So when the sample data will get increased, so by dividing the n and n-1, between the distance, between the difference between the n and the n-1 becomes very negligible. So that the sample mean or the sample variance will be approximately equal to the population mean we have, which will give us the most predictive result, the most accurate result when we are going to pass the data through the to draw some conclusion, to give some result, okay, by hypothesis testing, by z-test, by t-test, or by some quantitative analysis. So this many it will give. Okay, so look at here. The definition that we have already learned is completely here. Okay, if it is the suppose we are taking some random sample from here, so the mean will fall here, but for this data the mean will fall somehow here. Okay, suppose we are getting some skewed data. Look at this type of data. In the from the end, the mean will here it is falling. Okay, so in this type of cases we have 4 diagrams here. Okay, so in this type of cases, have you ever analyzed that we have learnt in the previous, that okay, why it is divided by n-1? So here is the conclusion. Okay, so due to the variance, due to the difference becomes large when we are dividing it by small n, that's why we are going to divide it by n-1. Okay, so look at this graph. This is known as the skewed data. If we will arrange, this is the population data and this is the sample data, then it is the data is skewed over here. Okay, here we are getting the mean. So this is all about our today's topic. If anyone have any questions, please ask me, so that I also get clear that okay, you have understood what I have explained you. Okay then, nobody have any question? Okay, so that's all for today topic. That's all from my end. Okay, now we will wind up this session. Thank you for joining and have a good day ahead.